Okay, so no one joined, no issue. I'll still try to explain the problem. Maybe in other meetings people will join. Anyway, so the question is very simple. Right here is remove linked list elements, and you're given with a list. You need to remove every occurrence of value, the val, that is 6 over here. So it becomes this resultant list. One edge case would be to if the value is at the very starting position of the linked list. That should also be handled correctly. So it is the linked list right here. If we take this as an example, so if we go by the iterative way, so what we want is we will create a dummy node so that we can handle the edge case. And let's say the value, finally someone came. Hi. Okay, so I just got started with the problem. So, okay, I'll start again, no issue. Alright, so this problem would be a small problem. It won't take much time, but since I'm going to explain the recursive solution of this problem. By the way, are you able to see my screen, right? And hear me? Text or something would work. Anything would work. Hello. Yeah. Okay. You are audible. Fine. Fine. Okay. So this is remove all elements from a linked list. Okay. So this question involves removing every occurrence of value. So 6 is removed from this and the obtained result is this. So if you look at any example, one edge case would be to remove if the value is occurring at the very first position. We'll take care of that as well. So if the val is equal to 1, that means you want to remove every occurrence of 1. And since the 1 is at the very beginning of the links list, so we want to remove this as well. So an iterative version would be to create a dummy node having a -1 pointer. And if we see that the next one is 1, next node is containing a value 1, then we'll simply link the node to the next pointer. Then we'll move towards here. We'll see, okay, the next pointer is 1, so we'll link towards 1. If it is again 1, then we will link this to null. That's how we're going to do. So that's an iterative version. All right, so that's an iterative version in which you focus on where any one particular node. Hi, we just begin with the question. So the question over here is basically removing all the occurrences of 1 in the linked list. So iterative version would be focusing on one node and either to include it or not based on that. So if you don't want to include it, just unlink from the next pointer. But we want to have a recursive solution. So recursive solution can work in a way that for a recursive solution to work, we have to pass on the function itself. And what we can do is we can pass this list and in the sub function. And after we are done removing elements from here, we can actually perform our decision. Let's remove this portion. We don't need a dummy node over here. So we can actually perform decision on this particular node, whether to include it or exclude it. So this is 1, right? And the value is 1, so we want to exclude this. So instead of, so, so we would be altering the head pointer and the list would become like this. So the entire list becomes 2, then null. h2 and null, right? However, if the case was basically, if the case was, sorry, so if the case was 3, that means, let's say the value was 3. So at that point of time, what we want to do is, since the value is not equal, so we want to include this value. Hence we will directly just simply link the next value. So what I'm saying is, so either we will link the head to the next node, or we will link the next pointer to the remaining list. That's what recursion is going to do. Okay, so instead of drawing the whole box, I'll just simply draw this, and I'll simply link it uh, by this only. Okay, like this only. This means I'm altering the next pointer, and this means I'm altering the head pointer. The, okay, now let's focus on a bigger example and look more closely on what the recursive call would be like. So the first recursive call would be right here. Yeah. So first recursive call would be this call, having h as the head node. Okay. So then the next pointer would be h2, would be pointing to at this node. And this, but at this point of time, the recursive function will call this sublist. So our next pointer at this point of recursive call would be like, sorry, h3. And then the recursive call will again call sublist, having h4 pointing to right here. Then our recursive list will be again called. The function will be called again recursively, having the last pointer, that is h5 pointing to null, right? So at this point of time, the green box, if we can focus on that, we see that the green box is null. H5 pointer is pointing to null. That means we want to return it simply. Since we return it now, what we want to do is we want to, now we are at the blue recursive call. So at this point of time, we want to remove the one because the value is equal. Hence, to remove it, we'll alter the next head pointer. Okay, yeah, that's what we're gonna do. So the head pointer will be pointing to null. Then we move on to the previous recursive call, that is here. We want to remove h1 because its value is 1. That's why we want to remove it. And to do that, we'll do just the same thing again. Instead of altering the next pointer, we'll move the head pointer towards h4. We'll equate that, and we'll do that. And how are we doing so? We are doing by, let's say, okay, over here we are doing h3 is equal to h4. Right here what we did is h4 is equal to h5. Okay, moving on to the next pointer, that is 3. Now 3 in this recursive call, the entire list is sorted. Our entire list have values removed, and the remaining portion is to either include it or exclude this element. So we want to include this element because the value is not 3. Okay, so instead of altering the head pointer, what we will do is we will alter the next pointer, and next pointer as in how we'll do this. Yeah, so we will equate the equate the h h2 dot next is equal to h3. So at this point of time, at this recursive call, we were getting h3 as we were getting h3 as the return value here. We are we are altering the next element. Why? Because we want to keep the current element 3. That's why we did is just equate dot next instead of equating this thing. So at last we return the h2 towards the recursive call, to this recursive call, and at this point of time we want to include this element because 2 it is not, value is not 2. What we'll do is, again, since we want to include this element, we won't be altering this one, we will be altering the next pointer link. So how are we going to do this? Just going to be doing this, right? And what's the logic over here? H dot next is equal to h2, right? So now let's traverse the list, collectively. Brown. So first we are starting from h. So we wrote h pointing to 2. It's pointing to 2. Then we move on to 3, 3, and this pointer is pointing, is going on, is equating, equal, and then finally the pointer points to null. So that is how it's getting done. So the whole uh, linked list which we at the end which we got is this. Now let's handle a different edge case right here. That is if all the elements are need to be removed. So for the first recursive call, h is the pointer right here, and the second recursive call, h2 is the pointer here. Yeah. So what you want to do, and the third one is like as usual, h3. Okay. So once the recursive call would be returned from here, because this is null, so you simply return it. All right. Uh, okay. So simply return it. That way, at this point of time, what we want is we want to delete this element because the value is equal. So to delete the element, what we did is we alterated the, okay, let's delete this. Yeah, so we alterated the head pointer towards the this h3. So over here, what we did is h2 is equal to h3, and right here, what we did is if h3 is equal to null, simply return, right? Let's mention the same case on the above case, that is the last one, that is if h5 equals null, simply return. Anyway, moving on to the rest of the portion, then we have then we are then the recursive call will be switched to this place, to this pointer where this is the head, and we want to remove this element because it's 1. So we will alter the head pointer, that is pointing towards here and here. So at this point of time, what we do is h is equal to h2, right? And if we just iterate through the whole list, we have first of all h, then the next value it points to as we go on is null. That's our output list. Okay. So now let's code this whole logic. Having this diagram in our mind, we can do this. Come on, a little more. Yeah, it's better. And right here we can actually go. So what we want is we want to call it recursively, right? But there are few conditions to it, and the condition is if the value is so first condition base case is the h5 is equal to null. Note that h1, h2, h3, h4 is just the head pointer in the recursive call, right? There's no difference. Every time the recursive call, the head pointer will be head only. So anyway, so in the case of having a green recursive call, green box, we will have this case. So we need to handle it. So if the head is null, how's it? So just a just a second. Sorry. Yeah. So if the head is null, then you simply return the head, right? Because you're simply returning it. So whatever h5 was there, that's getting returned to the previous function call. So this is done. Now there are two conditions. Either the condition is this, where we want to keep the element, or we don't want to keep the element. So let's just write it out. So keep the sorry, remove the element, and for that we do something. If else, and else we will else we will keep the element. So for the removing element, what's the condition? So in the blue box, you can see that the h4 is the pointer, right? Or even if you can see the below, so if the recursive call jumps from this position to this, where h2 is the head pointer and h2 is pointing to 1, so that is the deciding factor that whether we need to keep the value of h2 or not. So the head is right here, that is the h2, it will act as h2. So whether the head dot dot value is equal to val, right? So if the head dot value h2 dot value is equal to val, when it is equal to val, then we want to remove it, and if it is not equal, then we simply want to keep the element. Okay, you're done with the two if statements, if else statement. But what do we need to, do inside it? So if we don't want to keep it, we simply equate the current head to the received head. So the first thing is like we equate the head to something, and in the keeping we equate the head dot next. So head dot head dot head hash next something. So that's what we are done doing for both cases. But at any point of recursive call, like we can see for the h1 h, so this whole function is getting called and whatever changes are getting made, and then finally the h pointer is h dot next is getting linked to the h1 h2, sorry, right? So you are making decisions based on if else statement, and you are letting the recursive function worry about the whole function, and in return you are getting a final output pointer. So I'll just call return element, and since and I'm calling head dot next dot comma value, So this is basically getting called at each point whether we want to remove the element or whether we want to keep the element. So removing element directly changing the head value, or keeping the element, that means changing the next pointer towards whatever the final list is. Right. So with this if else statement, we are altering the current value. If we are checking if we want to keep it or not keep it, and the rest of the function is worried about is going to be handled from the recursive calls. Now once we are done with that, once we are done with having every linking setup, and we're finally at the last recursive call, would be just simply returning it. Return the head, because because head is what we are altering it, and rest of the function is handled right here. Once we're done with that, we're going to be returning head. Okay. Anything else? Let me just quickly glance through it. No, it seems fine. Let's try running the code. Sorry. Let's try running the code. Accepted. Let's try submitting the code. Yes, it got accepted. Any questions regarding this? Recursive call.
No question. No question.
Okay, okay. It was a pretty easy problem. So yeah. So I'll be explaining the remaining problems at the remaining time I posted.
Yes.
You can carry if you want any help, you can do that. So I guess that's it for this question. We'll see you at next maybe 7, having merge case sorted linked list. And that question is using a heap. So I'll be explaining a heap data structure and how to use a heap data structure. Okay.
Sure. Yes.
Yeah. Okay then. See you. Bye bye.
Yeah. Bye.